Hello again YouTube, and you join me looking into a bag. So again, it's nearly Christmas and we have a load of lights here which are the old-fashioned, let me grab them, tungsten fairy lights. So what I'm going to do is replace these with LEDs for this set, and then these have these sort of shady things on there, which is nice if you like that type of thing. But this is the set we're after, so we're going to turn these to LED. So to turn these LEDs into LEDs, we can just pull these out, take the bulbs out and replace them with an LED itself. But these are 12, 30 watt bulb, 12 or 30 volt bulbs, and they're all in series because you've got a 240 volt supply. Because they're in series, the voltage is divided up against each bulb in series. Now an LED runs on around about 3 volts or so. So if we just replace the LEDs of LEDs, it would all blow up and go horribly wrong. So we've got to fit a small power supply in here to drop the voltage and the current down. So this is a current limited supply which I've built here. And it works on the principles of a capacitive dropper. So we have a capacitor in series with the rest of the string of LEDs, and that puts the current and voltage out of sync, out of phase, and that causes a current limited supply to be created. So we have this side, we have the AC input, cap in series, fuse, bridge rectifier, and then a smoothing cap on the output, and this is where the output is, plus and minus. This is a circuit board I designed myself called Catalina, because why not? So I'll be putting this in series about here, wrap it with heat shrink and stuff to make it safe, and then change all the LEDs. So here's my plug, here's my cable, and we're just going to cut the cable. Right, now we're screwed. So here is that circuit board connected. So I've got on this side, turn it over so you see the joints. This side I've got the plug, so 240 volts comes in there, and rectified DC, current limited DC out on this side to the rest of the lights, which are down here somewhere. So that's the power supply I needed to do. What I'm going to do later on, I'm going to heat shrink all this and glue it and everything so it's safe. I'm waiting for the heat shrink to come in, so for now I'm going to put a bit of tape on the bottom just to protect it, and then leave it dangling and make sure no finger touchy. But yeah, this is perfectly safe. So because this is an old string of lights and some of these bulbs are blown, if I change one of these for an LED now, it won't light up because this is open circuit. So the first thing I've got to do is work out which polarity this is. So I've got the one end up here. So if I measure the voltage from this end to the very beginning bulb, I should work out what polarity, which way around it goes. As long as all the LEDs point in the right direction, it should light up. Should. By the way, my circuit board's there, so it's completely safe because, you know, all I need to do is tread on it to be electrocuted. So I've just got to remember not to do that. And to make it a little bit safer, only a little bit, I've wrapped in Kapton tape. I've also put some heat shrink down here, which I'll heat shrink it up to make it, again, a bit safer. So I've measured the voltage. This is the very first plug and this is the very end plug. So very end plug is minus negative along the big chain, and the very first plug is positive, and it's 296 volts. Yes, 296 volts between these two plugs, and that's because we're taking it from the mains and rectifying it, so that would make sense. When you put the LEDs in and it's current limited, it will pull that voltage down to about 3 volts per LED. So all we've got to do is change the bulbs to LED. Always test your LEDs first when you get a new bag. So just a power supply hooked up across with a resistor, and then we can get our filament bulb. What we do, we straighten the tails, so these are normally sitting like that. We put them up like that, and then the bulb should just pull out like so. And then we get our LED, we unplug it, put it through. Quite tricky doing this one-handedly. 2 seconds. I'm back again. Put it through like that. Make note of which side is positive, which side is negative. You can push it down and then bend the legs over. And then they can go in, keeping note of the positive and negative, and the positive's got to go to the positive side of the lead, negative's got to go to the negative side of the lead. And once you've done one bulb, you can then do all the others. So I'll quickly finish this one off and show. So the LED's in, I've bent the legs over and trimmed the legs so they sit nicely. And that will just fit in the holder, and as you can see the LED, so you can see the long anvil shape is the negative side. So that negative side's got to go towards the negative lead on the string of lights. And again, it's just a push fit into the holder like it would be with the filament bulb, and that's one bulb done, converted. So I've got to do the rest of the string of LEDs, and then hopefully that will all work. Hopefully. And with all the LEDs now fitted, the string is illuminated. And as you can see here, they're all LEDs shining away nicely. And so that improves the efficiency, and that also improves their life. So if we look here, the numbers are upside down, but we are looking at 1.9 watts of power for the entire string. That's not much, is it? So what I've got to do now is put some heat shrink over the power supply. I'll do that in a separate video because there's a way I want to do that that's relevant to all things that are like that. So for now, I shall see you later. Bye.